Thank you, everybody. And we are going to continue our panel discussion this afternoon on AI for transportation. And so this panel discussion will be moderated by Professor Yafeng Yin. And I would like Professor Yafeng Yin to introduce his panel. And so Professor Yin is the Donald Cleveland Collegiate Professor of Engineering and also the chair of the Department of Civil Engineering at the University of Michigan. And I would like Dr. Yin to introduce his panel.
Okay, good afternoon, everyone. It's my great honor to moderate this session on AI for transportation. So today we celebrate two major milestones. Over the past 6 decades, I think UMTRI has been a global leader advancing traffic safety and also mobility research. And during the past decade, MCD has really accelerated innovation in CV technology and applications. But despite decades of progress, today nearly 40,000 lives are still lost every year on US roads. And also the average American drivers spend 43 hours stuck in traffic. That is more than 5 working days behind the wheel. So the cost of congestion reached tens of millions of dollars nationwide. So this panel really is to talk about how to leverage AI, artificial intelligence, to reverse those trends and build a transportation system that is safer, more efficient, and more equitable. So this is how we're going to go with the panel. I will first introduce our panelists, and also each of them will take about 5 minutes to share their perspective. And then I'm going to impose a few follow-up questions to get more insight and also hopefully open the conversation across the panel. And then in the end, I will leave some time for audience Q&A. So please take a note of your question as the discussion unfolds. So with that, I would like to introduce our distinguished panels. I would like to start from Gregg Brunner, Chief Operating Officer at MDOT, C.J. King, Chief Technology Officer at Torc Robotics, and Qiaozhu Mei, Associate Dean for Research at Yafeng School of Information, and finally, Wenbo, Assistant Research Scientist at UMTRI. Okay, thank you all for joining us. And I would like to invite each of you to share your opening thoughts. I would like to start with Qiaozhu, who is a leading scholar at Advancing AI and Data Science for Societal Impact. So Qiaozhu, the floor is yours.
Well, thanks, Yafeng, for this very warm introduction. So I am a computer scientist by training. I have been working on AI for decades. And in fact, if you look at how AI has been applied to transportation, it's not new. It has also been there for decades, right? Look at the GPS, on your car, right? When you want to find the route, you rely on search algorithms. When we book flights, we rely on recommender systems. Right, and many other applications with AI as well. So why are we so urgent about AI now? Well, from the computer scientist's point of view, I think that this is probably because that AI has reached critical threshold. We can see that in many applications, especially like in handling text, right? AI has already passed the threshold from being demonstrable to being useful. Right. Large language models like GPT handles text. But this is not just about text. This trend is seen from many parallel domains, parallel modalities. Right. We have models surprisingly well performed in handling images, making videos, dealing with time series, sensor data, user behavior data, health data in particular. Right. So all these modalities, the emergence, we call that, in all these modalities is creating, a synergy, right? A synergy that, we can really build, real-world applications and a synergy that raises public attention, right? So, AI is literally transforming every aspect of transportation now. If you think about, your autonomous vehicle, it understands the road based on vision, right? And it, make predictions based on lots of data. It make decisions based on real-time planning, right? And it communicates, with the drivers, passengers, with natural language. So every part of this is now handled by AI agents, different AI agents. They're not good at everything. Each one is good at one thing, and they work together, right? And some of them are deployed in the cloud, some of them are on the car, right? So that's actually creating this transformative moment, right? And also, as the computer scientist, as the AI researcher, I'm also often asked, why do you care so much about transportation, right? Why is transportation such a target domain for AI? I would say that transportation is the perfect test bed for modern AI. And this is because that it's complex, it's messy, it's dynamic, it's interactive, right? And this complexity really challenges many limitations of AI nowadays. I can give you a few examples, right? So right now, if you look at GPT and these models, they're called generative AI models, right? So they're trained to make predictions of what's next, make predictions of the next sentence or the next frame in a video, so on and so forth. But what they're not good at is understanding the world, or so-called the world model, right? And in the world model, the task is not to predict what's coming next, it's to predict, what the general environment will change, will be influenced if you make this or that decision, right? Well, with GPT, it's probably not a big deal because when we're writing emails, it's fine that if we don't interact so much with the outer world. But in transportation, we always do, right? Whatever decision that the vehicle makes is affecting all the other cars, pedestrians, right? Bicyclists on the road. So that's one, the road model. And second is how to balance between all these complex objectives. Again, if you think about GPT or Gemini, they are optimized to make the users happy, right? I answered your question, and maybe I'm careful enough not to speak wrong stuff, right? Bad things. But in transportation, well, it's not just like arriving on time, which is hard today. Arriving on time or driving smoothly. It's all about safety, security, right? That's mentioned in the morning, and it's about different objectives, right? It's about sustainability. It's about fairness, right? It's about real-time decision making. So lots of all these objectives are mixing together, and how to find a balance between them. That is not what the modern AI is good at. So that creates such a test bed, right? And finally, but not least, transportation is a perfect test case for human-centered AI, which I think is the heart of modern AI. Why? Because we want to build AI models that augment people, that does not replace people, right? We want AI models that collaborate with people, right? And this is true in transportation, because transportation is not the AI problem. It's also the human problem. And it's not a one-person problem or one model problem, right? It is on the road that the AI models interact with human drivers, human passengers, and with other AIs, other people, right? So how to actually understand each other's behavior and how to incentivize each other to collaborate, right? To coexist, co-evolve, right? This is the hard problem of human-centered AI, right? So to summarize my perspective and to inspire the other great perspectives, AI is transforming every aspect of transportation now, and transportation provides the perfect test bed for developing modern AI models, especially for all the agents, models, objectives, especially human AI collaboration. Thank you very much.
Okay, thank you. So now let's hear from Wenbo, whose research advanced safety critical AI for transportation systems. So Wenbo, please share your perspective.
Sure. Yeah, thank you, Dr. Yin, for the introduction. So everyone, I'm Wenbo Sun. I'm a research faculty at UMTRI. So I mainly work on the field of the AI methodology for transportation safety. And today I have to share some of my experience in this field, which were jointly developed with my colleagues at UMTRI. So the the transportation safety system can be mainly divided into two types. One is called active safety, the other one is the passive safety. So the active safety refers to the ADAS or ADS systems that mainly utilize the sensing systems to drive the vehicle maneuver to prevent those crashes, while the passive safety system itself is mainly utilize the the airbags or safety belt to prevent the occupants from injuries during those severe crashes. So with development of AI technology, there are lots of new works emerged in the recent years for both of the systems. So there are multiple perspectives of the AI safety for active safety in this field, but I mainly focus on the research of the AI generalizability and also the AI reliability in the field of active safety. So for example, we can train the AI model in one field using lots of data, and then eventually we would like to apply the AI model elsewhere, right? For example, we can train a sensing system to recognize pedestrian, recognize road markings or signages. Then a deer just ran on the road, which is very common in the state of Michigan. Then if the AI model has never seen it before, it can probably recognize it as something seen before and then make some dangerous decisions. And also there are scenarios that you train an AI model in an urban area during the sunny days, and then you would like to drive the vehicle again in the rural area during rainy days, right? Then the domain shifted and you still want the AI model to work. So basically, we work on the research to make sure that when you apply the AI model from one domain to the other, you still want to guarantee the AI model can first aware of it is working in a different domain. It has something it never knows. And also, we want to make sure that with limited data collected in a new domain, we can transfer the model from one field to the other. So you would refer this type of research as the auto-distribution detection and also the transfer learning. Moreover, as the more and more data accumulated, we can still have our AI model to evolve, right? By introducing more and more tasks to let our AI model to learn new things. However, this is very common that when the AI is picking up new tasks, it forgets what it learns before. So we're trying to develop some AI methodology to make sure that while your AI model learning some new things, it does not forget what it learns before. And you do not have to collect lots of the existing data before, and we call this type of research the continual learning, which are also very critical for the AI generalizability in the field of the transportation research. And on the other hand, we also work on the passive safety side. The passive safety means that how you adjust the safety belt or airbags to protect the occupants and also VRUs from those crashes, unavoidable crashes, right? And within those fields, in the past, most of those passive safety systems were designed to protect the specific targets. For example, they designed and validated those safety belt and airbags based on a specific target, for example, mid-sized male. However, now, with the AI power increase, we'd like to see whether we can improve this existing passive model so that it can protect the whole population instead of just a selected small portion of the subpopulation, right? So that's the basic idea. So to do this, we developed some AI model to predict the corresponding injury risks at different combinations of the subject variables, for example, the age, gender, BMI, and also different designs of the vehicle settings. For example, the inflation, deflation speed of the airbags, and also the tension on the safety belt, right? You can always make the prediction using the AI model. Then we can tailor different designs for specific subjects. Probably for obese people, you're going to use this tension. For these lean people, probably you're going to increase the airbag inflation more, something like that. So then we can tailor the safety belt, the passive safety system for specific subgroups so that the whole population is going to be better covered and protected. So that's our ongoing research on the passive safety area. And then eventually, we still want to integrate these two parts of the system together, right? Because in the past, the active safety system are mainly developed for crash avoidance. And passive safety systems are mainly developed for injury mitigation during unavoidable crashes. So there are two isolated systems. Now, with the increasing AI power, we're trying to see whether these two systems can be integrated with each other. That said, for example, when we're making the driving maneuvers, we can consider potential protection performance of the passive safety system and then determine whether you can tweak the vehicle driving direction a little bit or slow down the vehicle. You can make all those decisions based on AI model. And on the other hand, when you are thinking about how you trigger the airbag, how you tension the safety belt, you can think about the potential crash pulse or vehicle kinematics introduced by the ADS or ADAS systems. Right, so these two systems should work together in real time, and we're working on some reinforcement learning algorithm to see how these two systems can collaborate with each other. So that's pretty much it based on my personal experience in the field of the transportation safety field, and I'd like to pass the mic to Gregg to talk more about the MDOT's view.
All right, thank you, and I'm proud to be here to continue the Gregg show today. Fortunately, I think I'm the only one that spells it correctly, though, with 3 G's in my name. So, no, just joking. Some great Greggs in the house today. But as an infrastructure owner operator, I was going to kind of give that perspective in terms of some of the things that the department is either looking at doing, we're in the process of implementing or piloting, or actually we are doing as of right now. More at a high level, the state of Michigan implemented an AI policy earlier this year, and MDOT kind of followed suit with an AI policy in terms of things we're looking at there. But from a Michigan DOT side of things, we're really focused on 4 key areas. One of those would be using AI for user interface. Next one, most important to me, would be safety and mobility. Next would probably be asset management, and then finally, probably the least sexy one, but data management in terms of how we manage the oodles and oodles of data that we have within the department. But first, on the user interface side of things, what's going on right now within the state of Michigan, as I'm sure you're aware, there's many different departments throughout the state. They're in the process of developing a chatbot, which if you're on a Department of Natural Resources site and want to search where MDOT carpool lots are, it'll pull up that data for you regardless of where it is in that michigan.gov web space. And likewise, internal, we're doing something for an internal search of our data. I remember I started as a design engineer way back in the 1900s. That's what my kids tell me to make me feel old. But, you know, back then everything was on manuals. So I had, you know, you're pretty cool when you had binders of manuals lined up all above your desk so you could grab at will to go through things. But I remember doing design work, and I'd have to go to my design manual to find this, but then it referred me to the construction manual to find this other part, and then the Astro Green Book to find this. So what we're doing is looking at combining all that information to be searchable from one spot internal to MDOT. Because when you look at studies, it's usually about 30 to 50% of an employee's time is spent looking for information. So if you can cut that in half, can you imagine how much more productive our folks would be just by having that information at their fingertips? So those are some of the things that we're looking at or in the process of implementing going forward, just on the more user interface side. And when you start talking about safety and mobility, that's kind of, when you start thinking about AI and transportation, I think that's what a lot of folks focus on, is how can we make the roads safer? From a safety standpoint, I know historically we've always kind of been reactive when it comes to crashes and preventing those. You know, you look at hotspots on a map that says this intersection had 10 crashes, what can we do there to fix it? You know, we've transitioned a little from that to be more systemic in how we do things by adding rumble strips, additional signs, those types of things in higher potential for crash areas. But what we want to be able to get to is how can we be more predictive in terms of where crashes are going to occur before they do. I know Yafeng mentioned about 40,000 people a year die on our roadways, which to me that's a ridiculous number, something we have to work on to improve. But by starting to look at using AI technology, which we're piloting at quite a few areas around the state right now, how can we identify where those near misses are happening? I know we're driving and we have all those oh crap moments where you almost get into a bad crash because someone cut you off. How can we identify where those are happening and potentially address them before they become dots on the map where bad crashes or fatalities have happened? So we're looking at a few different systems and areas around the state in terms of where we're doing that. Another one we're looking at is identifying wrong way driving using some of our video camera technology, AI within the camera technology to identify where cars are going the wrong way onto our freeway ramps to prevent some of those horrific crashes from happening. Once those are identified, it can be run through our Transportation Operations Center and subsequently to state police to be able to get out to address some of those, again, hopefully before they happen. And beyond that, just looking at kind of mobility, when you start thinking about our corridors, in particular, you know, when you think about technology, it's traffic signals. How can we improve traffic signal timing along a corridor? Right now we have the ability to go in and automatically adjust signal timing along a corridor based on congestion starting to build up. But again, how do we move from there to using info from connected vehicles to anticipate where congestion is going to happen, to be ahead of the game for those types of things, to help people get where they're going safely? The third thing is really asset management. We start talking about that and the number of assets that MDOT owns that we inventory. Just to put things in the ballpark, we have over 50,000 culverts that we have to identify, find their condition, rate, just to make sure those are safe. We're looking at technology right now where you can go in, an inspector can take a picture of those, and it's going to automatically give the size, type, any condition concerns that are out there, if the culvert's perched, if there's vegetation in the way, those types of things. So again, it's making people's jobs faster, but what my goal is to get people out of the roadway when they're doing these types of things. Again, just to address the safety issue there. So we're working with a separate vendor to look at signs and guardrail. To give you an idea, right now, those are all collected by hand on a little device like this for the inventory. To give you an idea, we have about 500,000 signs that we have to inventory and maintain. So we are working with a vendor right now that has the ability to pull camera information from commercial vehicles, front-facing cameras that can identify signs, inventory those, and guardrail. But not only that, as they're out on the roadways, if one of those signs is damaged or hit, the ability to notify us that something's been hit, we have to take care of, which historically right now anyway, we rely on either a police report coming in or a call into one of our offices that something's been hit. So again, to be able to stay on top of that or keep guardrail in good condition, those types of things, which takes hours and hours and hours of man time right now, to be able to automate some of those processes, I think is going to be huge going forward. And the last thing is probably just our data sets that we have overall. We have tons of data out there in terms of roadway condition, asset inventory, all those types of things. But unfortunately, a lot of those is just sitting there as data right now. So how can we kind of go through and turn that data into information that's easy to access for folks around the department? Again, but all this gets back to the quality of data that we have. So we're gonna have to kind of go through things at a first step to kind of cleanse some of that data to make sure it's correct. Because when you start using AI, the data in, data out is gonna be key. So that's one of the things that we'll have to look for going forward. But at a very high level, beyond that, it's not just on inventory or those types of things. One of the operations things I forgot to mention was we're even using it in how we plow snow. Our snow plows actually have what's called a maintenance decision support system, which actually uses machine learning, which is a subset of AI. Utilizing that, we have already loaded in the roads, the pavement type, whether it's concrete or asphalt, any conditions associated to trees hanging over the roadway, those types of things. So we have the asset data going in, pavement temperatures from the snow plow, and then the forecasts from the National Weather Service in terms of what's coming. We're able to use that information to give hour by hour recommendations to our snowplow drivers in terms of if they should be salting, if they should be just blading, or doing nothing to let the salt work going forward. And then using machine learning, that's continually updating those forecasts and recommendations going forward. So I know when you start thinking of AI, you think of all these amazing high-tech things, but it's even down for little things like plowing snow. So that's the kind of thing we're trying to get in our folks' mindset, is how can we better use that to improve everybody's day-to-day lives that are out there. But with that, I can keep things going down the line to CJ.
Yeah, hi everyone. Thanks you guys. So I think I get to bring a practical application that we're actually putting into the market that covers everything that they've already covered, from research and advancement on active safety all the way down to collecting of data and bringing that in. And at Torc Robotics, we're delivering a hub-to-hub autonomous truck. So 53-foot Class 8 semi. It's gonna be fully autonomous, no humans in it, and it'll run from a hub to another hub so that then it can be distributed so that we can take a lot of the hard problems out of logistics today and actually bring a lot of goods to all of the consumers faster. And we started that with, when Torc was founded, we started with saving lives. That was our mission. As we've grown and gone through that, we've pivoted into the trucking industry about 5 years ago, and that's where we're going into that long haul trucking, which is actually a huge target for safety overall, right? And as we bring that together, we do it in 3 ways. We think about how we govern it safe, operate it safe, and engineer it safe. And if we go through all of those, governing it safe is kind of typical what everyone would think of in a self-driving solution. How do you actually put in the right guardrails? How are you setting up the right safety processes, safety controls, bringing all that together? And the operate it safe, that's where we actually run and build out our entire mission management, remote assistance, all of that, bringing it back to a centralized hub. And how does that tie into the logistics centers? So when Gregg mentioned when a sign goes out or there's a backup, we're feeding that same type of information back into our control center to alert the vehicles that are coming up that same route, all ready to start determining if they need a new route or to change different or be able to handle a different scenario, whether it's a construction or a police officer directing traffic based on any type of accident. We are already relaying that through that. And then when we say engineer it safe, that gets into the whole space around AI. So we do what we call AV 3.0. It's a combination of full end-to-end reinforced learning and then also with a heuristic guardrail. And it's really important that we talk about both. Heuristic guardrails, the original robotics, it would take so much data to be able to build that out and get it. But think of that as that's how we know as humans whether our kids, so my son just turned 16 and I'll use that as an example, is he safe enough to drive the vehicle? Is he going to do all the right things? Does he know enough about the rules of the road? All those things are kind of how we can build out heuristic guardrails to make sure that it's not doing anything unsafe. At the same time, the learn solution all the way through with that reinforcement learning with introspection in the middle of it allows us to actually understand, look at each piece of the models, because we have multiple models going through it, to really understand how each one influences the end game. So it's not one big black box of a self-driving solution, throw in a bunch of input, get a bunch of output. We're able to introspect and say, if the sign is missing, does that impact it? Does our overall fusion between our different sensors, does that set up and change how we see this? Or when we're doing prediction, a lot of it's humans are the hardest thing to predict. And so we do that. I think someone mentioned deer being in the road in the Michigan. We actually had this happen, not deer, we actually had a lawnmower. Someone drove a lawnmower right down the middle of the road while we were running in robotic mode. Our truck was able to recognize it and know it was we use transfer learning, right? Just like you had mentioned. We knew that it was a vehicle that was moving at slow speed and we were able to track it just like we would in any typical vehicle. We tracked it for about a half a mile where it drove 5 miles an hour on a 45-mile-an-hour road and stayed behind it before we turned into our hub. But those are real situations that you're not ready for, you wouldn't think of, and all that reinforced learning and generative AI that goes into the synthetic data creation. So now we have it recorded, we have all that data, and now we have thousands of scenarios with lawnmowers every which way. It's not something you would think of, but we now have that type of thing running inside our system. So really bringing all that through the whole ecosystem to understand how do we actually leverage this to make all of the roadways safer for everyone. We talked about the 40,000 accidents that caused life loss here in Michigan, but we're doing this everywhere and looking at these long haul. A lot of times these are happening in remote areas where emergency systems can't actually get to, because if you're driving from here to Texas, there's lots of area where there's not, a ton of folks in the area, but there's a lot of traffic that goes through that on these long haul areas. With that, I think we turn it back over to start off the questions.
Okay, thank you very much. Those really are wonderful opening remarks. You really set the stage from fundamental research to safety application to implementation and also industry perspective. So let's dig into a little deeper on some of the topics. So I'd like to start with a couple questions for each of you. And once one person answers the other panel, well, feel free to chime in. So let's have some conversation across the panel. Okay, so Qiaozhu, you mentioned in your remark a co-evolution of human and AI systems. I imagine in the future, right, near future, you have CEV in the traffic stream, and you have human intelligence interacting with machine intelligence. So and also those intelligence are co-evolving. So what's the implication for research and policymaking, considering this possibility?
Thanks, Yafeng. That's a fantastic question. It's also a hard one. OpenAI and Anthropic both released a report recently about how people were using their models. And then what's surprising is that the frequency of users interacting with the models, like you go multiple rounds of interaction, actually drops, right? This is surprising because you want people to interact with model more, but the reaction, the truth is that when people saying that the model is doing great in simple tasks, they begin to just trust the model. I mean, you just handle all the things. I don't need to actually be informed. Right, so that's one way that you can see that humans' behavior is actually adapting, is changing while the model's capacity changes every, 3 to 5 months. Humans' perception and behavior towards the models also changes. In transportation, we see that there are cases that autopilot is increasingly reliable, and we increasingly trust them to make decisions. But on the other hand, that they always show this hard corner cases to human drivers to handle, which is not really a good sign, because you can see not from human cognition that it's really hard to wake me up and handle this very hard problem, right? So the question is, how are humans perceiving, how are humans trust AI in certain tasks and not others, and how we imagine that AI is being a co-pilot, a collaborator, or just like we dedicate tasks to them. So in all these cases, you can see that AI models evolve, humans, competency, AI competency, and humans' perception also evolves, right? If only that if we can measure them, if we can measure the trust of humans and AIs, and if we can measure the AI readiness of human drivers, human researchers, and also the human ready factors of AIs, and then we track them, right? So now will be super useful, signals for governments, for researchers to handle. Maybe we can build this AI readiness map, right? And maybe this matrix will be like our GPSs for governments and industry to really navigate through AI deployment and such. So that is just 1 cent of my thought.
Okay, thank you. So I have been amazed by large language model and how they can do. But my understanding is the large language model has no word model inside them, right? I think that you guys, the computer scientists, are trying to develop the AI model with a digital world model within them. So if you guys are successful, then for example, the CEV could have consciousness and become fully autonomous. So do you think that there's a possibility for that? And also, if AI has a world models, and so AI can create simulator of traffic behavior and travel behaviors, and then how they interact with physical system, how they interact with mobility system, and we could use that digital world to test the transportation innovation before we put them on the road and in the sky. So could you comment on those two? There's two separate questions, I guess, and could you comment on that?
Well, again, fascinating. So, that's my hope, right? If you look at large language models, they are optimized to predict the next tokens, right? But in transportation, whatever we do is going to influence the environment. It's going to influence what others do. And then, the whole ecosystem will change. And it's true that large language models don't really have the capacity to understand the world, to understand, the global environment. And that is why that transportation is such a wonderful domain. That you mentioned the deer, you mentioned other animals, creating the simulated world scenarios. And my Silicon Valley friends told me that if on the road, if there are just all autonomous vehicles, then the problem is much smaller, right? But in the foreseeable future, it's like a mixture of AIs and humans, right? So to build such a world model, what do we need? Right. Well, obviously, we need to understand, the road conditions, the weather, right? All these, policies, rules, and these. But we also need to understand behaviors, right? AI behaviors, human behaviors per se, right? For example, that there was the classic study showing that if you put an autonomous vehicle within the circle of human-driven vehicles, surprisingly, the congestion disappears. I also heard that if you're driving in Silicon Valley, right, if you see the Google car, you cannot get into the lane. You just find a Google car and get in front of it, because we know that they are driving conservatively, right? So at School of Information, we're building this so-called foundational model for human behavior, right? And that is taking lots of data like this, experimental data, observational data, literature data, and such, trying to understand what's actually behind human behaviors, how humans make decisions. And imagine that if we can build a digital twin for everybody in the world, then we can simulate, probably many of these conditions, but we can't. Right, we don't have enough understanding about individuals, and it's probably restricted from doing this for privacy reasons. But if we can understand the behavior traits of people, if we can understand under what scenarios that this group of people are more likely to make more risky decisions versus conservative decisions, then we can build cluster, we can build abstracted value levels of digital twins, and then to really simulate the world.
Okay. Thank you. So Wenbo, do you see any possibility to use this digital twin to improve transportation safety? Or more broadly, which area of AI research are most likely to improve transportation safety?
Mm-hmm. Yeah, thanks for the question. So actually, we do appreciate the development of the digital twins to improve the transportation safety. For example, it's in the real world, whenever we want to test the performance of like say a passive safety system or active safety system, we cannot always just crash a car, right? So there are different environments to simulate the whole process using different fidelity of simulations, and also probably some of those can be generated from some existing generative models as well, right? So basically, we're trying to establish some digital twins of the real world, but with some kind of fidelity that we should calibrate, because we cannot merely rely on the simulation model. We still need some field data, some additional data to calibrate the simulation model, so that first, the digital twin itself should be reliable. Then we can utilize the digital twins to generate lots of data, and then think about how we optimize the system, how we maximize the protection effectiveness for those occupants we are using other vehicles.
Okay. Yeah. So I have a biggest fear for AI, because the biggest fear for AI is we don't know what we don't know, the unknown unknowns, right? So you mentioned about AI safety systems. If you put a lot of AI safety system in the system, a lot of them, unexpected risk can emerge, right? So how we can, because you're doing all the safety, AI safety systems, so how do we responsibly deploy those AI safety systems to this critical domain where life are at risk?
Yeah, thanks for this fascinating question. So I'd like to say, as a start, I'd like to decompose the whole system, the implementation of the transportation system into 3 key modules, right? Input, algorithm, and output. So definitely the most important part is the algorithm. It's just the AI algorithm where we just do a lot of research and develop the whole part to, for example, trigger the airbag, trigger the safety belt, or like brake the vehicle. So that's the algorithm part. But I mean, the more important thing should be the input and output. So regarding the input, I'm talking about the data or information collection system, right? Because you have to know how far the pedestrian is to the vehicle, how the other vehicles are driving, right? So for now, we have different types of the data collection system: radar, LiDAR, camera, different types of the cameras. But I think one thing we need to improve before fully implementing this transportation safety system is that we have to calibrate and know how those sensing systems can work, right? For example, you can definitely detect the pedestrian using your camera, but you don't know how far it is away from your current vehicle. The closer the vehicle is to the pedestrian, the lower uncertainty you can have about your inputs. Then you can plug in your input into your algorithm, then get your decision, right, for your safety decisions. But how close is close? Like, what will be the sensing errors and in the sensing system, and how much error will be passed into your algorithm, then resulting in different uncertainty in your decisions, which will trigger type 1, type 2 errors, or false positive and false negatives in your decisions, right? So I think Now, although we already have a good system to collect the information, but we still need to conduct some additional analysis or conduct additional experiments to know what will be the capability of our current sensing system. And then we need to further pass those uncertainties into our AI algorithms and think about uncertainty quantification of our output as well. So yeah, that's just based on my current experience on this transportation safety area.
Okay, thank you. Gregg, so in your remark, you mentioned about AI promise major efficiency and safety benefits, but it might also deepen inequalities if not managed properly. Do you agree this is a legitimate concern? How does MDOT ensure that AI benefits are distributed equally among different communities?
Yeah, again, like I talked about previously, it's something we have to learn to manage, and as Wenbo had kind of said from a safety standpoint too. Lots of what's going on, when people start talking about AI right now anyway, they think of generative AI. I know when we talk to our folks where, help me write this term paper or make this email sound professional, those types of things. But that's just kind of the tip of the iceberg when we start talking about AI. We're moving towards agentic AI, where that really helps out in the decision-making process, not just providing info or making things better, but gets to that decision-making process. And for some people, I think that's where things get a little bit scary, or they get uncertain about things in terms of how we get there. How do we kind of keep our arms around things to make sure that we're falling back on safety as the number one thing we do? So again, that's the direction we're starting to go, knowing that we don't want the wheels to fall off the bus or anything like that. But again, a lot of that comes down to, though, just developing our workforce in terms of our approach to AI. And when you start talking about new technology overall, and this is not just AI, this is any kind of technology. You kind of have your sprinters, your walkers, and your sitters. You have some people, once you show them new technology, they want to grab it and go with it. Kind of have your walkers that are like, yeah, when this is good and I'm confident, we'll implement it. And then you have the sitters that just kind of say, this is the way I've always done things. It works for me. I'm going to go through all these manuals on my desk and figure things out. So really what we're doing is looking at kind of how can we we'll let the sprinters do their thing, keep pushing forward with the checks and balances there, but how do we turn those walkers into sprinters? How do we turn those sitters into walkers to kind of continue to move the needle? But a lot of that's just been through the education process. Probably within the department, we've done 50 or 60 different presentations to different areas around just to kind of explain AI is, how it works, and then just to get ideas from folks on how we can better implement that through our daily functions within the department. Lots of these for technology is good. Lots of people see technology and they want to implement technology, but a lot of that gets down to what's the problem we're trying to solve here, and that's what we're trying to wrap our arms around. Overall, is some of these big picture problems that are out there, how can we use AI and other initiatives to be able to solve those? But again, that gets down to a lot of the partnerships that we're already have and are working to develop kind of throughout the industry.
Okay, so we haven't talked about one important question, which is the implication of AI on jobs, right? Do you worry that AI is going to displace the human workforce? And in transportation, how might rapid advance in AI research replace human roles?
I wish AI would handle my email for me so I didn't have to do that. I could replace that task. But again, it's going to be kind of like anything that we've done throughout the years. I remember when I started, we were kind of as an engineer, we were kind of in the transition from hand-drawn plans to CAD plans. And the same question came up then, is I'm going to lose my job because this computer is so much faster at drawing things out, the draftman would say, or whatever. And again, it's just kind of the natural progression as we go through things. Then the internet came out and everybody freaked out that the internet was going to be out of control in terms of information overload for folks. And now we're moving into kind of the AI generation going forward. But I don't see it as replacing jobs. Right now, folks within the department are so busy because we have limited staff numbers. It's going to help us be more efficient in what we do and really focus on a lot of the key measures that I think we can use to make a difference. But a big part of that really gets down to the partnerships, like you had mentioned. When I talk about solving problems, That's one of the things we really rely on our research program to be able to do. I know we partner with UMTRI and many other universities that kind of solve a lot of what we consider our research problems. So we find some big problem with transportation, send it to go through our research program, send it to the researchers. They come back in 3 years, 2 or 3 years, or however long that project takes with what their research showed and recommendations going forward. I know I was just reviewing like our last research proposals that came in. A lot of them are for AI. You can imagine that if we were to do that and look at a research project for AI that started today and got done in 2 years, it'd probably be pretty old. So how do we kind of work with our partners in research to be able to accelerate that process, to refine it, to keep AI research kind of on the cutting edge, to expedite things, keep things moving forward. But not only that, with industry partners. Almost every day at work, I get emails or calls from sales folks or other contacts about, I have this snake oil right here that's going to be the newest AI invention out there. I think any salesman says AI and they think that's the golden ticket to be able to do that. But it might solve one little problem. And right now we have lots of small companies and startups out there that are solving one little problem. But how do we look at combining those all together to solve one big problem? I think that's going to be the next big hurdle we have to get through, and that's going to be all of us working together. Whether it's the department, whether it's research and industries, all kind of working together to be able to figure that out. Because right now things are moving so fast that it's hard to wrap your arms around with all the changes that are happening all the time.
Yeah, that's great. So CJ, so from your perspective in the industry, what innovation or breakthrough in AI do you believe hold the greatest promise to transform transportation in the near future?
Oh, that's
maybe
a good
next
question.
5 or 10 years.
In the next 5 to 10 years. I think we're right at the cusp of a bunch of changes that are happening now, especially around synthetic and generative AI actually coming and building that out. We mentioned agentic AI earlier, and that's coming in. It's all going into the simulation right now, right? Because we're not going to look to put that into a vehicle yet, because it's going to be difficult to prove all of that predictability and that determinism through that type of solution. But it does allow us to use it in a synthetic space to create the scenarios, like I mentioned, around different things, or really build out all the edge cases that you don't want to see. We don't want a truck to come to a near miss. We don't want to do that, but we have to have those aggressive actors inside our simulation models, and those simulation models have to be grounded to real world miles so we can validate and say it's correlated. So if we run this in simulation, it runs and works exactly how it does in the real world. And those aggressive actors inside of it, we want them in our scenarios. We know how our models will be deterministic in learning what and how to react to them, so we can actually show and predict and build out those cases. You know, we're going to collect millions and millions of miles. We already have them. But to prove it, we're probably going to run simulation on billions of miles. And so think of going to the moon and back 6 times, and that's the amount of data that we'll be using to validate and prove that our models are safe to do that. And you can't collect that amount of data. That will take too long to do that. And so that's where that's the biggest approach and change, is how to really bring that synthetic data creation on the very input. So whether it's on training models or validating models on both sides of that solution, really bringing that together allows us to move much faster to solve problems.
Okay, thank you. So I guess from your perspective, what would be where do you see the biggest opportunity for academia and government to support industry application or adoption of AI in transportation, from maybe through research, policy, or standards?
Yeah, I think that's a great question. We work actively with, here in Michigan with MDOT, we work with Texas down there with the DOT, we're working with the federal government. It's regulations around this to enable the right things to be set up and organized, and that being proactive and working to set up how we do it safely, how we do it organized, so that we can share information and really build it from the very beginning. We don't want to launch something and walk to the government and say, look, here's what we have. We want to start now and explain how is the process we're working. It's the educational process and controls together. And I think there's a lot of active work going on through that, whether it's actively working with NHTSA or MDOT or the Texas DOT. All of that for us specifically is very proactive and working a lot. We have a whole regulatory team that works very closely, brings up, here's how we're doing it. And then a lot of times it's just bringing our safety information forward. Here's how we're thinking about the problem. Here's how we're documenting it. Here's how we're actually proving it and bringing that forward. That part and getting the research on others to validate that that is the right way to go forward and what we're proving, that's really how it's changing and allowing AI to come into this. I'd love to hear Gregg's thought on how that works.
Any response from?
I agree.
Perfect.
Okay, it has been.
Again, it's gonna take a team approach. I think that I've already touched on that a little bit. It's gonna be all of us working together, not only to kind of keep AI between the guardrails, since we're talking transportation here, so that things don't get too out of control, but kind of that whole checks and balances process to validate that decisions we're making, those types of things, are safe and in the best interest of the public. Again, it's not one thing any of us can do on our own. It's going to be a team approach, and that's where we're going to have to all come together and kind of look at those big picture problems we want to solve going forward.
Thank you. So there has been a fascinating discussion among our panelists. Now I would like to bring in our audience. If you have any questions, please raise your hand, and then we're going to bring a microphone to you. When you ask questions, please state your name and tell you where you're from.
Hi, my name is Gabor Oros, and I'm a faculty in Mechanical Engineering and Civil and Environmental Engineering, University of Michigan. And what really fascinated me here is the plethora of scales you guys are operating at, right? So as Yafeng mentioned, if you say 2-year-old AI models, that sounds like, big history. But when we're building, for example, infrastructure, then it's, it's going to be there for 20, 50 years or even more. And when you build a truck, for example, that's going to operate there for its 7-year, life period and so on. So I would really be interested in, from your perspective, how you view this kind of as a challenge or opportunity that you have to actually work across these scales if you want to make, transportation advance with AI.
I guess that's a question for you, Yafeng, as the moderator.
I leave the.
That's a really good question. I think if you look at it, a lot of the stuff we're going to do in the real time in a couple of years, the models on that. But yes, the infrastructure all over the US is years old, right? 10, 20, 30 years old. But that doesn't mean that it's not safe and we can't bring data. So a lot of the stuff that we'll be doing, so we have cutting edge real-time detection on the signs and all that stuff. He's mentioning that he's looking for that type of data and how to bring it in. We'll have all that, and bringing that back in faster to them allows that infrastructure cycle and all that to be reduced while we're actually noticing and having to handle it, because we're not going to get a whole change of an infrastructure. I mean, we all live around here, or a lot of us do. 275 ramp has been, I think it's going on 9 months that we haven't been able to get onto 275 from 14. So I think that's if we start looking at it, we have to scale in real time for us and the advancements we're pushing on, but then we have to bring it back to help the ecosystem, because at the end of the day, we're all part of this together. And whether it's how do we help and support them in every area they're doing with the data and learnings we know, plus how do they work and understand what we're doing so they can at least validate and support us in our launches and where we're going. So I think it's a combination. It's not going to be, yep, that's old or this one's new. It's how does it blend together, and it's a conversation. It's ongoing.
Yeah, and when you start talking about the infrastructure itself, lots of it is just built to standards. At the time, curves are a certain radius, bridge underclearance, all those kinds of things. So those are really somewhat fixed in terms of what we do. So like you mentioned, even if that's 2 years out or farther, but really what we're looking at is more infrastructure's out there, how do we operate and maintain that kind of throughout the life cycle of the project, where we can use it to identify pavement conditions and potentially then help us learn what's the recommendation for this pavement condition here to make it last even longer. If you look at the distress in the pavement, looking at how things had performed previously or historically, being able to help us anticipate those going forward to help things last farther. So again, it really gets down to kind of operating what's out there and then using it from an asset management approach to maintain it and hopefully extend the life of the assets.
Hi, Dr. Smith-Jackson from RTA again. I am curious, from a mobility perspective, what type of research or applications for AI beyond just automobiles, like buses, trains, boats, planes, are either in place, in progress, or needed?
Lots. No, again, when you start talking about mobility, it's such, I think when people mention mobility initially, they just think of cars and how you get where you're going. But at least at MDOT, we look at the entire system, whether it's any of the things you mentioned, transit, air, not as much water just yet, or passenger and commercial vehicles on our roadways. But really what it gets down to is how do all those different modes interact together to keep folks safe? Lots of the things I had talked about in terms of crash detection or near misses, again, that's applicable to any of those different modes. So how can we use that technology together to be able to work through things? One of the big things we've been looking at is kind of the commercial vehicle front in terms of warnings. I know we've had some horrific crashes in Michigan this year where things will slow down in a work zone. One semi may stop, the car behind it may not, and then the semi behind that doesn't even touch the brakes. How can we get information into those vehicles about things going on ahead? And again, that's applicable to buses, cars, not as much airplanes and drones just yet, but we're involved in all that space, kind of trying to coordinate things, how we keep everybody safe out there and operating together.
Yeah, in my line of work, we develop models to support planning of the multimodal systems. So those models are AI-driven models. So it's just better plan multimodal system and coordination among different modes, including those active transition modes.
My name is Moshe Becker. I'm coming from Israel. I had my PhD at the time where UMTRI was still HSRI, if you remember those days. It goes back more than 50 years now. And my question to the panel goes as follows. We do feel in Israel, because it is called a startup nation, a lot of innovations go on, that the AI activity for research, development, patents, but various things is on a verge of exponential explosion. Not that every patent is going to be translated into reality, because this takes time, and this is what UMTRI is doing, trying to translate things into reality. And it seems to me that with the development of so much AI, and especially the problems, and I'm not talking about malfunction of the technological parts of AI, I'm talking more about the problem of cyber. I didn't get any view about you with so many developments related to AI. How do we control that the implementation of AI will not come and be blocked by a big wall of cyber? And the question is how we can give an answer to prevent all the problems that cyber can bring. I'll just give one example about a psychology that goes now in Israel. It's related to the Chinese industry with automobile production. And some will say, it's a rumor, I don't know to what extent it is true, yes or no, that built in so many systems, electronic systems in the motor vehicle, and also in control systems that are all computerized, that in China they built in now special corners where they can activate with malfunction when they have an interest in that. And I'm not going to spell out what are the possibilities. So the question is, how do we, scientists, people of technology, prepare ourselves to the explosion of so many innovation AI that can be attacked by malpractice and, as I said before, the situation of cyber. Thank you.
I guess
I think that's a really good question. Yeah, I can jump on. Ours is a little bit different, I think, because one, for our vehicles and where we're pushing a lot of our stuff, we can close that off, and it's in an embedded system, so we can actually do a lot of our cyber protection around our security and robustness around the actual system. Sorry, yeah, I was saying in the truck itself, we can actually do a lot of things on the truck, right? So we can protect that, not get access, and that where you start to get into the cloud, into other environments while we're doing that, I think that's where there's a continual learning. We have our entire security team that works directly with our safety and our security offices and is proactive in the cyberspace really bring in the cutting edge information and that. So it's, I think ever since, any internet started and the cybersecurity's been a space, right? We have to build security in from the very beginning into our product, just like we have to do safety. So everything we've talked about has been safety up here. We're doing that exact same process and philosophy with the cyber teams and really focusing on how do we stay ahead of that from our space. Now in research, I think I'll turn it over to you guys to kind of focus on how that steps in.
I'm not doing cybersecurity.
I guess on the MDOT side of thing, again, cybersecurity is huge in terms of what we do. And I think the biggest thing that we'd have to watch out for from an AI standpoint is that when people get too comfortable with the results that are coming out, if you're using agentic AI to make decisions for you and you're not verifying those, that's if somehow hackers got in and changed algorithms around or whatever else to push out bad results that aren't being verified by staff, I think that's the concern we run into. At the state of Michigan, anyway, cybersecurity is a huge thing we deal with and the number of hits we take every day from hackers. Somebody told me, I'm drawing a blank on what the number is, but it's unbelievable. If all those folks could use their powers of bad for powers of good, that'd be a lot better place, but that's probably a whole different soapbox to stand on to talk about. But again, it's something that's on our mind with anything technology-based, from not just AI, but anything we do from our message boards that are out there that occasionally get hacked and other types of things. It's something we continually monitor and, again, are going to have to keep pushing going forward to stay on top of that.
Thank you.
Yeah. So yeah, thanks for the question. So actually, I'm not in the field of the information security, but yeah, based on my limited experience with the AI for transportation safety, I think to really enhance this cybersecurity, we need to think about like two main perspectives. One is that regarding the real data that we need to pass from the end to end, and also from the end to our central control system, and then making the decisions. We need to think about how we compress the data, and also to make sure that when you are communicating between different servers, the privacy related things should be like removed. And then, for example, we can use some black box algorithm to project those to some features which cannot be recognized by the third party, and then just do this information communication between different servers. And also, regarding the final decision, I think one main limitation of the current AI algorithm is that most of the AIs are black boxes. So if you do not evaluate whether the decision is safe or not, you can just simply run it, and then it may cause some like separate security issues. So I think that's why it motivates us to develop something called the explainable AI, to think about whether you should validate, to further use the physics-based knowledge or transportation-based knowledge to evaluate whether the decision makes sense or not. If it just go out of the bound, then we just think about that there could be some potential issues, and then we just try to avoid it.
Okay, thank you. Last question.
Hi, thanks. Thank you to the panelists for all your thoughts. So this unique opportunity, oh, by the way, my name is Scott Moore. I'm at the University of California, Berkeley. This is a unique opportunity. We have folks from academia, industry, and government. There we go. You can hear me now?
Yeah.
We have folks from industry, academia, and government, and I want to ask you a question not about AI for transportation, but I want to ask you a question about education for AI for transportation. So, namely, the innovation and technologies are changing faster and faster. It's accelerating. Meanwhile, bachelor's degree at a university has remained 4 years. So I'm kind of curious for those in government and industry, what do you need, or how should we think about continuing education for AI as it accelerates and changes, for those that are kind of more on the consuming side, and for those on the production side of education, how do we rethink how we continue to educate folks and how to use these tools? Thanks.
Let's kick it off.
Yeah, I can. So that's actually a really good question, because this is something we're going through. I mean, it's the speed of change inside of AI and where we're going and trying to build out models and kind of the whole understanding and bringing that into a vehicle. In the last 5 years, it's gone through, let's say, 3 generations of change. So someone that just started school went through 3 that is coming out now, and a lot of our folks in the industry hadn't gone through that path, right? So for us, it's actually teaching of the process and the system to understand it. So then when the new generation comes along, they don't have to relearn it. It's a new process, a new tool that they can so a lot of system engineering is what we're actually starting to see bring a lot more value into an AI space. So someone that can systematically think through how it's working to be able to explain it. So a lot of us, we're starting to dive into questions in our interview processes to say, how are you using this? How does it work? So you understand the process itself. And then actually we're able to adjust as new technology or new papers come out. You know, we still need to do the research and we still support a lot of that in our connections to different universities. But like really, how do you think through the process so you can then expand that and like keep going? That's probably the most influential to us, is really to keep teaching that part of the process.
I guess on the infrastructure side, I'm a civil engineer, or back in my former life, I was a civil engineer degree from college. I'm a PE, but that's now just a professional emailer. I feel like that's all I do. But it's going to kind of be through continuing to look at the needs that are out there. I know when I started in civil engineering, or lots of us when we went into civil engineering, it was about picking the right materials for asphalt, or how do I design this roadway? It wasn't really technology based in terms of, not as focused on operating the system, it was more about building the system to be able to do that. But that's really shifted, and so is what's been going on at MDOT. We used to only hire civil engineers to do those types of tasks, but now that's opened up to anyone with an engineering degree can apply for any job at MDOT. Or any engineering job, I'm sorry, at MDOT. But beyond that, it's a lot more in the technology space that we're dealing with too. If you would have told me, 10, 15 years back how involved in IT we would have to be to operate our system, whether it's our traffic signals or ITS or anything else that's going on out there, again, it's a continuous involvement to be able to keep up. When you start talking about AI though and transportation, it's the folks that are coming into the department are the leaders in AI right now. They're like, give me the tools to do my job. Like, we don't have the tools yet, we're still working on them. But again, those are the folks that are gonna take the leadership roles in AI, in my opinion, and transportation going forward. So what's going on at the universities and just in general right now with folks being accustomed to using AI and how to better use it, they're gonna be the ones that are solving the problems that we have right now. Once we identify those problems, how do we get there? Those are the folks that are really gonna step up and be able to do it.
Yeah, I cannot agree more. So this is the question that we're just debating every day with my colleagues. Techniques evolve fast, but mindset does not. So it's extremely important to teach students the mindset of being innovative, being a problem solver, right? So in a way that, if you look at how we're teaching machine learning and all these techniques, we're probably overfitting the existing knowledge, right? And as Wenbo said that, for the AI model, it's extremely important to, generalize towards the unseen data, right? Outsample scenarios. Humans are too, right? Instead of overfitting, what we know about AI models, right? It's more important to learn how to adapt to the new environment and then how to find the solution, how to build the solution. And that is exactly the unique value that Michigan is hoping to provide. Thanks.
Yeah, that was a really great question, okay? This is, as a CE chair, this is a question we constantly thinking about. But in the interest of time, I'll keep it short, right? So anyway, I think we should continue to educate students and instill them the fundamental engineering knowledge, and then teach them how to work with AI. And so essentially, AI as an agent to help with the engineer to design and manage the system, operate the system. I hope the final agency is still the human who make that decision. Now the AI, when they become conscious, they make their own decision. I mentioned this is my biggest worry about AI. Okay, so in the interest of time, we need to wrap up this panel. Thank you very much for all the multiple questions. Please join me in thanking our panelists.